In this lesson, I'm going to show you how to calculate opportunity costs and determine who has the comparative advantage in two goods productions using what's known as the input approach or the input method. Let's start by looking at the table that we have in front of us. Notice that on the left we have two different goods. Countries X and Y can grow 1,000 watermelons or build a single bicycle using the number of workers indicated in the table. So this is called an input table because the data in the table refers to the number of inputs needed to produce a single unit of output. This contrasts with what we called an output table because the data in an output table, which I demonstrated in an earlier lesson, showed us how many units of output could be produced with a fixed amount of inputs, whether it was time or number of workers or amount of land, etc. The difference here is that we are now looking at how many units of input are needed in order to produce a single unit of output. So let's demonstrate how to calculate opportunity costs using the input method. We see that country X can produce 1,000 watermelons using 4 workers, or it can build a single bicycle using 12 workers. The question is, if country X chose to grow 1,000 watermelons, how many bicycles would it be giving up? To answer that question, we can do a little bit of simple math. So for each 1,000 watermelons, 1,000 watermelons, we'll just call that 1W because that's what we're looking at here. 1,000 watermelons, we'll just call it 1W. Country X would be giving up, how many bicycles could it have built with the 4 workers it took to make 1,000 watermelons? Well, it's giving up 4/12 of a bicycle. How did I come up with that? Because it takes 3 times as many workers to build a single bicycle as it does to grow 1,000 watermelons. So the result here is that for each watermelon that country X produces, it is giving up only 4/12, that is 1/3, or I like to express opportunity costs in terms of decimals. It's giving up 1/3 of a bicycle. It takes 3 times as many workers to build a bicycle as it does to grow 1,000 watermelons. What about the opportunity cost of bicycles in terms of watermelons? One bicycle requires 12 workers to produce, whereas 1,000 watermelons only requires 4 workers. So for each bicycle it's building, it's giving up the 3 watermelons that it could have produced with those 12 workers. The 12 workers needed to build a bicycle could have grown 3,000 watermelons. So the answer here is 3 watermelons per bicycle. Let's look at country Y now. Country Y needs 6 workers to grow 1,000 watermelons. So for each watermelon, how many bicycles is it giving up? Well, it could have only produced 6/24 of a bicycle because 4 times as many workers are needed to produce a single bicycle as are needed to grow 1,000 watermelons. So for each watermelon it produces, or each 1,000 watermelons it produces, it's giving up only 1/4 of a bicycle, or 0.25 bicycles. With the 24 workers needed to produce a bicycle, country Y could have produced 24 divided by 6 watermelons, or 4,000, or 4 watermelons in this case. To come up with these opportunity costs, what you need to do is determine how many of the other good could have been produced with the resources needed to produce a single unit of the good in question. 24 workers could have produced how many? 4,000 watermelons. So the opportunity cost of one bicycle is 4W, or 4,000 watermelons in this case. Now that we've calculated our opportunity costs, all we need to do is determine who has the lower opportunity costs in each good's production, and that will tell us who has the comparative advantage. Let's look at watermelons first. Country X gives up 1/3 of a bicycle per watermelon, whereas country Y gives up only 1/4 of a bicycle per watermelon. Country Y clearly can produce watermelons at a lower opportunity cost. So country Y has a comparative advantage in watermelon production. 1/4 of a bicycle is cheaper than 1/3 of a bicycle, giving country Y the advantage in watermelon production. And not surprisingly, country X has the comparative advantage in bicycle production. It gives up only 3 watermelons, or 3,000 watermelons per bicycle, instead of country Y's 4 watermelons per bicycle, giving country X the comparative advantage in bicycle production. So let's review. What was the main difference between the input approach and the output approach? Let's have a look at the output problem that we did in an earlier lesson. In that table, we were given the number of shoes per minute and the number of basketballs per minute produced. The input time was fixed and the output was variable and demonstrated in the table. Using that information, we calculated opportunity costs and determined who could produce each good at the lower opportunity cost. And through that, we drew conclusions about who had the comparative advantage in the two goods productions. In an input problem, the main difference is that the output is fixed, a single unit of watermelons and a single bicycle. And what we are given in the table is the variable. In other words, the number of inputs needed, or the number of workers in this case needed to produce a single unit of output. We had to determine what was given up when the 4 workers needed to produce 1,000 watermelons were producing watermelons instead of producing bicycles. Once we had the opportunity cost determined, we once again found who had a comparative advantage in each good. Now, if countries X and Y were to trade with each other, country X would export bicycles and country Y would export watermelons. And through trade, they would both be able to enjoy a higher level of consumption of both watermelons and bicycles.